Welcome back to Ox Tools. I'm Tom. So for those new to the channel, this is an episode of Meatloaf, and that's a mixed bag of shop-related and engineering-related subjects put together into a single video. There's usually something for everybody, shop-related. So in this one we got some flea market finds, some Craigslist buys that I made. We had a Northern California meet and greet of metal workers and machinist types down in Morgan Hill, which was pretty cool. We've got the Bar Z Industrial Summer Bash coming up in June. And for those of you that don't know, this is a chance to meet YouTubers and fans, and we have all kinds of tools and raffles and actually swap meet. It's pretty nice event. I go every year, and this is Stan's and Koski down in Southern California. So I'll put some stuff in the description so that you can check it out and sign up if you want to go. And then we got the Hickory Dickory Dock, the results of the different handle treatments for hammer handle treatments. We've got the Loctite and the linseed oil and the antifreeze, and we've got some test results from that. So and there's probably some little surprises in there. So let's get cracking. I think this is going to be a good one. So we're ready to do some final testing on these handle treatments, and these are the hickory dowels that we put in antifreeze, linseed oil and turpentine, and then Loctite 290. So these have had the chance to absorb for a week, dry for actually 2 weeks now at this point. And what we want to do at this point is evaluate these samples to see how well they've done. So what's the criteria? Good question. Absorption, and then any change in the structure of the wood would be the criteria that I'd be interested in. Did it get harder? Did it stay the same? Did it swell or expand? Or so there's some things that we can do. We have a control sample that's unmolested here, and then 3 samples that were treated differently, taken out of the same dowel. In fact, just adjacent to this. So, we can say that these are, approximately equal. So, anyway, I'm kind of excited because I've kind of been examining these because there's kind of some unexpected results, which is always what's cool about doing this kind of testing. Is you go in with these kind of preconceived ideas, this will work, this has always worked, etc., things like that. And I was like, oh, well, that's weird. And lots of interesting journeys begin with that statement as oh, that's strange. And then you start kind of digging into it and taking a look at it. So let's look a little closer. I got some evaluative tests kind of set up that we can do on these, and see what's happened to them. So let's check it out. So the first characteristic that I checked is the diameter. So, and the way I've laid it out here is I've got characteristics, the control, Loctite 290, linseed oil, and antifreeze, just kind of in the order that I've got them laid out here. So what I did was, since this wasn't, so I marked one end of each one, and the marked end is the end that was in air when it was in the liquid, or in each of the liquids. So what I'm doing is I'm measuring the diameter at the distal and proximal ends, right, to see if there's any change in the diameter. So there's some variation in the wooden dowel, right, and you see that here in the control. One end is 1 inch 003, the other end is 1 inch 007. So that's the control sample, and then so let's take a look at the here's the Loctite 290, and there's the A end. I marked it, and then we see that it appears that it's swollen a little bit. It's slightly larger than the control, but uniform, relatively uniform end to end, right? Okay, so that's kind of nice. So it swelled up a little bit. I think we can conclude that reasonably well. So then we get the linseed oil here. Excuse me. That's now this one absorbed all the material, which is not surprising. This was the lowest viscosity here. You know, it had a solvent carrier, basically, the turpentine. So we got 1 inch 005 on one end and 1 inch 0025 on the other end. So, you know, based on what we're seeing with the control sample diameter and the linseed oil diameter, I'm going to say that that really didn't change diameter much, okay? We'd have to do a lot more testing to make a conclusion about that, but, you know, a hard conclusion. So it looks like it didn't change. So now the interesting one here is the antifreeze. And you can see in the sample here, this is the end that was in the liquid, this was the end that was in air. It really only absorbed, you know, approximately halfway of the dough. But when I picked it up the other day, it was kind of surprising, and I noticed that this end that was in the liquid after it had dried had flared. And you can see that in the numbers here. So that's how it is. So 1 inch 006, which is kind of expected because that's what the control diameter, and we didn't absorb into that area, so that sort of makes sense. But the other end, look at that, 1 inch 33 thousandths. Now I took, just so you know, I took two dimensions parallel with the end grain and at 90 degrees to the end grain, just so you know how I did those measurements. I took two measurements and then I averaged those measurements. So, but that's kind of remarkable. And in fact, you can even see it. Let's see, I don't know if it'll come up on the camera. Yeah, it's kind of hard to see on the camera, but there's a slight flaring at this end. Actually, I rolled them on the table on a flat plate, and this one, you know, started to take a little turn because that end is a little bit bigger, right? Which is kind of interesting. So anyway, that's kind of cool. So volume absorbed, it was 6 milliliters to start. This one, you know, is about half. This is 0 was left, or, you know, 6 was absorbed. And some of this is evaporated in the 2 weeks that it's been sitting here. So, but it was more than that, so I'll just call it 2, so I'll fill those in. And then what we'll do next is we'll do some, I got a way to do some kind of hardness tests on this to see if there's any change in hardness. So we'll do that next. So let me go over the test setup with you guys here. So what I got is a little arbor press here, and I made a little arm here that we can put our scale so we can pull with a known force. So that'll all be relatively uniform, sample to sample. And then what I have, oops, where's my tweezers? Okay, I gotta get my tweezers. I got a 1/4 inch ball in there, steel ball, hardened. And what we're gonna do is we'll do a minor load to kind of seat the ball, and so that we have a uniform seat. And then what we'll do is we'll pull a major load, and then what we're going to be looking for is penetration into the sample. So they'll all be zeroed after the minor load, and we'll apply the major load, and then we'll see relative penetration. So it should give us a clue about hardness. I'll do 2 tests on each end, 90 degrees to one another, to see if there's any differences depending on which way you're coming at the grain. So we'll do one end grain and then side grain. So, but I'm set up for side grain right now, so we'll do those first, and then we'll do end grain, both ends end grain. Okay. All right. So I'm gonna just so that there's no diameter change here. I mean, this control sample is pretty easy to tell apart from all the other ones. So, so we'll do one at each end here. So let me get, I got to capture this ball here so we don't lose that. Oop. Like that. Whee! Okay, I can see it. I got to go get it. So, having dropped plenty of things, the natural instinct now is to just freeze and watch for movement on the floor. All right, let me get the dummy one out here. All right, and what we'll do, so that we're on the A end, put the ball in. And there's a little, there's a hole in the end of the ram. Make sure I'm centered up. Yeah, that looks pretty good. Okay, let's see. Can you see the indicator? All right, so actually at this point it doesn't really matter. We're not going to measure. We're not going to measure penetration until we do the major load. So actually, let me roll this around. I want to have some way to, I'm looking at the end grain so that I don't want to be too close to the edge either. So I'm kind of, so the grain is running this way, the way my fingers are in this particular case. And just for fun, we're just going to zero this up and see what kind of penetration we get at 5 pounds. Okay, so with 5 pound minor load and 10 pound major load, I think is what we're going to do here. I got to very carefully creep up on 5, 3, 4, 8, 9. Okay, there it was. 5.04 was the peak that I saw there. And as you can see, that's 15 thousandths of penetration, which is kind of interesting. Okay, so now let's do this. We'll zero the indicator. Okay. And so we're not moving anything. So now I'm going to apply the major load here, which is 10 pounds. Eight, 9, okay, 10.02. Okay, and this is actually kind of expected because the initial penetration, it's an infinitely small contact point theoretically, right? But as we push it in, the force is a curve, right? Because more and more the ball is being pressed into the material, right? So that's why we do this initial, this is how our normal metal hardness tests are done, or plastic hardness tests too. A minor load and then a major load, right? So now, all right, let me record this before I bozo this and forget it. So this is side. And this is the control. So what did we get? We got 11 and a half. Let's see, I'm just going to mark parallel. 11.5 mil. Okay, all right, and then I'll repeat this at 90 degrees. I'm probably not going to film all this because it's pretty well. You know what? We'll do I'll film at least one segment off each of the samples just so you guys can see that. Otherwise, it's a lot of kind of boring video, me fumbling around with balls. All right, so we're getting ready to do this is the Loctite 290 here that we're doing. And we're going to do the A end first, parallel to the end grain. Okay, get set up here. Oop, God dang it. This ball is, I should probably make a little holder for it. Oh, okay, there we go. Hey, I magnetized it. Now it's staying in the end of the thing. All right, let's get our scale in here. Turn that on. So this is our minor load here, 5 pounds. I'll do that first. 3, 4. I'll hit that one right on. Okay, 10th out. All right, so we don't use that reading. All right, so read 0. Now we're going to go to our major load here. 6, 7, 8, 9, come on, 10. Okay, and we got about 10.5 thou there. All right, 10.5. Okay, and then if I'm lucky, oh yes, a little bit. All right, and we'll go. Okay, and just for fun, we'll see where that goes. Okay, minor load. 3, 4, 5. Okay. 15. Okay, it's pretty much the same. All right, now let's do major. 8, 9, 10. Okay, and we got about 10 thou there at 90 degrees. Okay. Okay, and I'll do the other end, and then I'll come back on the next sample. All right, I got the linseed oil and turpentine sample in now. We're set up parallel to the grain, and we're going to do our minor and major loads here. All right, then I'll flip it around and do the other end, and then do the next sample. All right, so we got the antifreeze sample this time, and this is the end that was not in the juice. So I'm going to show the full one here because this end should, be equivalent to the control actually, because it doesn't have any antifreeze in it. But the more interesting end is the end that did absorb, so I want to be sure to show that. Do our minor. And I'm gonna call that 11. 11. Okay, all right. And now let me set up and we'll do end grain, and then we'll look at our numbers. All right, so we're set up on our end grain now, and I got the control sample in. So we're going to do the same thing, a 5-pound minor load and a 10-pound major load, and I'm just going to do one in each end instead of a bunch of spots on each end. So it's definitely a lot less penetration. That was a minor load, and I noticed that the penetration was quite a bit less than the side, which sort of makes sense. Okay, oh yeah, definitely less there. What is that? 5 thou. Okay, control, that's the A end, 5 mil. Okay, and I say mil, I don't mean millimeter, I mean mil as in thousandths of an inch. It's an interchangeable term with thousandths of an inch. They use it to measure I did the 10. Yeah, I did the 10. I gotta, don't lose track here, Mr. Wizard. Okay, okay, it's gonna stay, yay. Okay, approximately the center. All right. They use it for measuring film thicknesses and things like that. You know, like plastic sheet and stuff like that. So it also means 1/1000 of an inch. For those wanting to know why I'm using that word. All right, so this is the linseed oil here. I thought we'd give a little close up on the ball. Okay, loading. 4, 5. Okay, 3, 0. Go for our 10. I don't know if you, I don't think you're going to be able to see much there. But I was getting tired of that camera angle. Alright, that was 10. And that's about 5 thou on that one too. And that was a end, yeah, okay. Alright. Get it in the center. Give her a little wiggulator. Okay, here we go. 5. Reset indicator. 9. Come on, come on. That last little bit is really hard. All right, that's 5.5. Oops, sorry. 5.5. Okay, center there. All right, so this is the antifreeze. Turn that back on. All right, do our 5. It's a pretty boring video, huh? All right. I mean, you can't see some of these displacements very easily. But if I just show you the test results, nobody's going to believe me, right? Isn't that how that works? Coming. Okay, so that's 5 thou. That was the A end, the air end. Okay, here's the end that was in the antifreeze. Wiggle that a little bit. Alright. Five. Okay, interesting. That was a bit more, huh? 5. I'm going to call that 8 because it's about 3/4. All right, well that's the only one that was significantly different. So okay, let's look at our test numbers here. So here's the data cleaned up a little bit, and we got characteristic, our control, our Loctite, our linseed oil, and our antifreeze samples. And the first one is diameter, and this was each end, end A and then end opposite. And this is a reminder, end A was the end that was in air. In fact, let me put that there. And so the control, there's a little variation end to end, and then the Loctite. This is post treatment. Okay, so these are post treatment. It grew a little bit on average. Okay, and linseed oil, yeah, not a lot of change noted. The biggest change and the big surprise was in the antifreeze. So it changed considerably. So it's the clear winner on diameter change. And then this is liquid volume absorbed, and we started with 6 milliliters. Obviously the control didn't have any. This sucked up about 4 mils. This sucked up all of it, 6 mils, and this sucked up the smallest amount, the antifreeze, at 3 mils. Okay, so volume of material needed is lowest with the antifreeze, and the largest change in diameter. So far so good. And then we get into end grain penetration here. This is with the ball, and so the control penetration was about 5 thousandths of an inch, or mils, 5 mils, and either end, and about the same. I don't know how good our resolution is with this particular test here, because these have some similarities, although when we get here you'll see there's a difference. So I don't know, the average is the same between these two. The major difference here is there was much more penetration in the end that was in liquid. So the antifreeze tends to soften the material, the wood, and we'll see that a little further down too. So it had the greatest end grain penetration. Good or bad, I don't know. The wood's softer after being treated with the antifreeze. And then side grain penetration, and this is also a hardness test here. Here's our control with an average of 10 mils penetration, 10 mils, 10 mils, 11 mils. So once again, a little bit softer, and although interestingly enough, the end that was in the in air, not in the liquid, had a high penetration number. So maybe it's just a soft spot in the grain. I don't know. So I don't know what we can conclude from that. But if you average all those out, overall the highest hardness is the Loctite, and the lowest hardness is the antifreeze. And then we got cost here. Loctite's the most expensive, linseed next. It's a 2-component mixture. It's 50-50 linseed and turpentine, and the antifreeze is probably the cheapest out of all of them, and it uses the least amount. So draw what conclusions you want from this. I personally am trying the Loctite myself. It produces the highest hardness, so to me that means the head's not going to move around, and it's locked in there, and the wood's hard. How much harder is arguable, right? And kind of minimal. Linseed smells the best, and it penetrates the quickest. This is a time-proven method here, so certainly valid. And the antifreeze is the big surprise here, that it's a reasonable solution to the problem. It's kind of, I don't know, it's a gruesome color, and you get, if you dunk your whole hammerhead in there, you got to clean it off. I don't know. So use the results for what you will. It was kind of a fun test, and I had some fun doing it. I hope you guys enjoyed the testing. All right, so this first one is we had this Northern California kind of machinist meet and greet, and I don't know, this is like the third or fourth one I think that we've done in Northern California, and machinists get together and we do a swap meet. Usually there's usually food, and we just get together and kind of hang out, and it's usually at a shop. So we get to check out somebody else's shop, and then talk about tools and and nerd stuff. Anyway, Chuck Bomarito from Outside Screwball, he gave me these squares, and these came from Kurt Armbrust up in Menlo Park, California, and he was passing them along to me and Randy Richard. So Randy Richard in the Shop, if you don't know of him. Anyway, I got them both now, so screw Randy, I guess. So, no, just kidding. So Randy, let me know in the comments which one you want. I have a couple of these, and if you need a big one or a small one, let me know, and I'll bring it down to the bash or whatever, or mail it to you if you let me know which one of these you want. Anyway, Kurt, thank you so much. This is a nice little treat. It's always fun to have somebody walk up to you and hand you a tool, and off you go. So anyway, thanks, Kurt. All right, this next one's pretty cool. This comes from a buddy of mine, Joe Way at the Sierra Specialty Auto. He's an auto head. Anyway, he knows that I like machine data tags and nameplates and stuff like that. So he sent me a little selection here, which is great. And these are like heavy duty ones here off of power boxes or motors or whatever. Which I forgot what this. Oh, this is off of a Cincinnati mill here. I don't know if they're all. Yeah, okay, these may all be off of the Cincinnati mill here. And then he also sent me some 7/16 bolts, which I don't have too many of because I'm not a car guy. And but he is a car guy, and he had a big bucket of bolts that he bought at the swap meet, so he sent me some. So anyway, go check out Joe at www.joeway.online and show him some love. And Joe, thank you so much for the machine plates. And I collect them, and then I mount them on backer boards when I get enough to make it worth my time. So anyway, I'm getting pretty close, I think, to doing another show board there. And anyway, thanks a lot, Joe. These are cool. Appreciate the thought. Thank you. So this next lot of tools is these are flea market finds, and there's a little itty bitty flea market up near what is it, Diamond Springs, which is kind of near Placerville, that we go to once in a while. A bunch of bugs in here. Anyway, I went there, and the guy had actually it's two different people here. So this was one buy, and this was a second buy. This was $3, and this was $4, I think. So it was priced right. Now I don't know about you guys, but this is like the 10mm wrench story, right? I always buy 9/16 wrenches when I see them. And this is a Thorson, and it's a little shorty, which is kind of nice. And then this is a Proto flex head here, and it just barely turns here, and this will clean up pretty nice, I think. And I don't know if you've never tried these are pretty good, actually. You can turn them like this. You can reach into areas and turn them, and then they kind of behave like a box wrench too, and so they're kind of nice like that. So and then this caught my eye just because, boy, I get some mosquitoes in here today for some reason. This thing caught my eye just because of its patina. And now I like buying tapered shapes because they're a pain in the neck to make, and when you need an alignment pin, sometimes you need one that a long taper, sometimes you need a short one, whatever, and you always hate stopping to make what you need, right? So if I see these for cheap, and this was cheap, I usually just pick them up and throw them in the chisel and punch drawer. So I should probably show you my chisel and punch drawer at some point because I got a pretty good collection. This is a Dasco, which is a modern brand, and then this saw some love here, hammer love, and I like tools to show their use, but this is one situation where. Okay, it looks cool, and somebody used the heck out of this, and it's a nice patina. But you don't want to have punches in this kind of condition here, in particular when they start cracking like that. And, you know, you laugh because you see this in the high school textbooks is, oh, always grind your chisels and punches, right? And it's no baloney. Because if you've ever been hit by a piece of this stuff, and I have, and a lot of folks out there have been hit by, and it's literally shrapnel. It's hardened steel, and when it fractures, it's sharp. And when, you know, you think about when you're hitting this with a hammer, the forces, the concentrated forces are pretty high. So it comes off pretty hard and pretty fast, and it's sharp. So I'll dress that up and put a taper on it so that it's happy again. But it is kind of fun to look at it and see that somebody used the heck out of that thing there. So anyway, that's that. And then we got a couple interesting things. This is a Starrett, caught my eye here, and it's a stud for a combination square. And occasionally these get screwed up. They get bent, or they just wear, or whatever. In fact, this one's got a little kick to it from excessive tightening or whatever. But you know, I have a few spares of these, and this caught my eye because it was a Starrett, right? And you know, it's nice to have a spare that's got a spring and a nut and the whole 9 yards there. And that's the little indexing, tit right there, so that it locks it in. And what that does is when you put the blade in, once the index notch is in, right, the blade slides in easy. It's not cocked when you put the blade in. Anyway, that's what that's about. So that's that. This guy here, this caught my eye because, and I have no idea what it was used for, but my first thought was some kind of watchmaking tool here. And it's actually sharp, so you know, somebody's probably using it as a cutting tool or a scraper of some sort. But I thought, my first thought was, oh, it's a watchmaking tool, and it's used to pry the backs off of cases or something like that. That was my thought. But you know, that's a romantic thought, I guess. It's you know, this is pretty crude looking too. But I like the handle and I like the shortness of it. So it's going to be my my watchmaker's case popper scraper there. So yeah, no maker's mark on it. And then this is actually a nice little Starrett depth. It's a depth protractor, and it has the original blade in it, which is cool. And it's got the little window, which is nice. And then this one is cool because, in fact, this is better than the one I have actually. So I'm going to upgrade my my little depth thing. Is if you lift it over, then you can actually use it like a protractor for some actually it's got an index mark on it, for some common angles, right? And which is kind of nice. So if you're going to buy one of these, this is probably the one to buy. Although I don't know if they sell this model with the protractor back anymore. I'm not positive. I haven't looked in the Starrett catalog. This is a number 236, I think. Is that what it says? Yeah, 236 it looks like. Anyway, like I said, it's better than the one I have, and I'll clean it up a little bit and put my old one in the trade pile, and you know, and go from there. Anyway, some flea market finds. So this next one is this is a Craigslist find. You know, I'm looking at Craigslist pretty regularly, and this thing popped up. There's actually a couple of them on there right now for pretty good prices. And what this is a this is a dynamometer. It's a crane scale, and this one is 20,000 pound maximum capacity, 100-pound increments. And the way this works is it's got a bar inside it, basically kind of a U-shaped bar, right? And there's a measuring device between the two arms of the bar, right? So when you load the scale up, that U spreads a little bit, okay? And this dial is calibrated to read that spread. And, you know, it's in the elastic range of the material, so basically it's a pretty linear line, right? So anyway, that's how they make these things. Now this is a big boy, and you can see it's got big shackles on the back here. Actually, maybe we'll pop the back off and have a look at the inside, but there's the bar. You can see the bar right there, and here's the cutout. You can just see the edge of the cutout there. I'm going to pop this cover off and we'll take a look at the inside there and see the guts of this thing. But $50. So now if you bought one of these new, you know, there are thousands. And now, do I need this? Yeah, I have one of these that goes up to 10,000, but I didn't have a 20,000. So I guess I needed it, right? But $50, it's a pretty good price. So, you know, I met the guy, out in Pinole, and looked at it. Hey, looks good. Boom, give him the money. I'm done. It's like a 3-minute transaction. So, but let me pop this out of here, and then we'll open the back up. And you guys can have a look at the inside and see what's in there. Well, hopefully these aren't going to be seized up or whatever. So we have a lot of these at work. This is kind of the old school de facto crane scale. Oh yeah, and you can see down in there. See the works here. So here's our U-shaped bar. That's the main load carrying element of the thing. And what happens is and you can see the one side of the mechanism is anchored to this side, and the other side is anchored to this here. And then what happens is these spread slightly. What's going on in there? What is that? It doesn't look proper. Maybe it is. Maybe that's the. Oh, I wonder if that's an overload. Oh, I know. I'm nerding out here. Sorry, guys. Anyway. So this beam here, this beam bends under load, and this measures, you know, the bending of that beam, and it's calibrated in pounds. It happens to be calibrated in pounds. So I was going to build one of these on the channel just for fun, but then I found this my $20 crane scale, and I said, yeah, I don't think so. I'm not going to build one for $20, and anyway, it's kind of fun, and they're quite simple, but because they're kind of a calibrated instrument, and the people that build these have to maintain standards and records and things like that, they get kind of expensive if you have to buy one that's traceable. So anyway, sometimes these are called dynamometers, and sometimes they're called crane scales if you're shopping on eBay, if you're looking. And the other one is proving rings. But proving rings are a little different than these, and they have a different measuring system that's used on them. Anyway, Craigslist. So this is another Craigslist score here. What we got here is some ladder levelers, and I've been wanting some of these for my big extension ladder, because living up here in the hills, the ground around the house is not necessarily level where you want to put the ladder, right? Anyway, this is one of those items that's like stupidly expensive, to order online or buy at Home Depot or Lowe's or McMaster or whatever, right? And so I kind of like made do without them, which is not the safest thing to do, right? And because these are very simple and quite effective, actually. Anyway, Guy had some out in Vallejo, listed on Craigslist, and I connected with him, and these are Louisville, and in the bag with all the fasteners. The bag is still sealed. All the bits are there, and $30. Now these are 130, I think, or 140. You know, if you buy them full retail or whatever, right? So, oh dear. What do we got here? Yeah, it's still got the made in China for Louisville ladders. But you know, they look proper and they look correct, and so I'll mount them up to my ladder. But you know, like I said before, I kind of keep my eye peeled on Craigslist for, you know, stuff like this, and I got a master list of junk I'm looking for, right? All the way down to ladder levelers, and you know, who knows what else is on the list, right? And so deals can be had, and yes, sometimes you got to drive a little bit, and but you get to meet interesting people, and you help them a little bit because they want to get rid of something, and you help yourself because you get something for you know, a reasonable price, right? So $30, yeah, I'm pretty happy, and you know, a 20-minute drive or whatever, and hey, I'm good, so I'm feeling good anyway. This next one's a test here, and I saw, I don't remember where I saw this. I might have seen it on Instagram or YouTube. I don't know what, but this is a steel cutting blade, okay, that fits, you know, one of these, a skill saw, and now what's interesting about this, it's not just carbide. It's a Cermet, okay, and for machinists that know about Cermets, these are reinforced carbides, basically, and they have little whiskers of I don't know what in them, but they are incredibly tough, and so much tougher than normal C2, C4 carbide grades, and so from an impact resistance standpoint, this is superior to carbide. Now, the weak link in all this is this braze joint here, right? And so, you know, the impact of this thing slamming into steel or whatever. So the teeth will hold up. You know, will they stay in the in the blade itself? Anyway, we're gonna try it. These were it was on sale actually, $34 at Home Depot in particular, and Lowe's didn't have these, so I had to get this at Home Depot. But we're gonna try cutting some. I got some half-inch steel plate here that was sheared, and so this sheared edge is kind of rolled over, so we're just going to take a trim cut off of that to kind of clean it up as a test here, and then see what kind of finish we get and how the thing behaves, and you know, how violent it is with using this tool here. So cross your fingers. Okay, I think I'm ready. I got a guide here. I've got the depth set, you know, at about an inch or so. This is half-inch steel, and worm drive skill saw. I don't know. All right, let's try it. Eyes and ears. Let's get set. I'll try to remember to adjust the sound level of the clip. All right. Okay, well, we got a result. That was interesting. I knocked out my lighting circuit here. But first impression is cutting like cream cheese. Let me go reset a breaker and connect up to a different breaker. So the breaker that I was plugged into happens to be on my lighting circuit, so it's already got some load on it, and the saw must have been drawing a fair amount. What is the yeah, this is a 13 amp saw, so plus the load I could see getting over the chips. The chips look pretty good, and there's not a lot of sparks, which is nice. So let's finish this cut, then we'll look at the cut quality. There's a little bit of heat in the off-cut piece, but so far so good. Let me put my ear stuff back in. Okay, contact. Geez, look at that. That cut quality is pretty impressive. I have to say that I'm pretty impressed. Now let's examine the blade and see how our teeth held up for that cut. Yeah, these are looking pretty good. And the way they got it set up. Okay, what's going on with that one there? Okay, so it's a different geometry every couple of teeth. The profile is such that it's actually a very strong shape. It's kind of got a radius to it. I'm not sure if you can see that or not. And then this tooth looks like it's a little lower. So it kind of gets the first hit is on a rounded tooth, and then the next hit is a tooth that looks like it's a little lower to me, so that it kind of gets a roughing and a finishing pass in one shot there. But I'm not seeing any knocked off with that particular pass. So how long does it last? Who knows? Depends how hard or how abusive you are on it. But I would give this kind of thumbs up. It's pretty good. And this is your Diablo Steel Demon, and this particular one's a 7 1/4. They have the smaller ones. If you have, so how this performs on a cordless saw, that might be a good follow-up test for this. A smaller diameter and a cordless saw. But on this one that's got buckets of power. This cut was cream cheese. The feed pressure was pretty low. Okay, that's about all I got for today. And be sure to check out the Bar Z Summer Bash. There's a link in the description, so you can go check it out and see what it's about. And if you want to meet some of your favorite YouTubers, a lot of them show up. Well, not a lot. A few of them show up. And we have a big swap meet, tools and materials and all kinds of stuff for sale. And then the other one is the Norcal meet and greet. If you want to get on that mailing list, get in touch with Uncle Chuck. There's a link in the description. If you would like to host one of those, be sure to tell him, and we'll put you on the host list. So a host basically opens their shop up and has some parking areas and for folks to show up and set up some tables and have some guests over. So anyway, check it out in the description. Hope you like the episode, and see you next time.